Yes, microphone is works. Everybody listen to me. Everybody listen. My report is entitled "The Influence of Molecular Oxygen on Energy Characteristic of a Gas Discharge of Atmospheric Pressure in Air with addition of carbon dioxide."
Юра, щелкни еще раз, презентацию не листает. А, нет.
Меня слышно?
Да.
Так. The aim of our work is to develop the CO2 laser based on the mixture with air and CO2 with the absence of helium. This laser need not complicated vacuum system, and it is possible to construct compact CO2 laser, compact and simple CO2 lasers. Here is the photo of samples of such. So there are two samples of such lasers. Here is a circuit of excitation of laser. Because we have to operate with a mixture without helium, that's why that we have to apply short pulses, the pulses with a short current to discharge gap. And for this purpose we used a Blumlein circuit. Which forms the pulses with a front of 50 nanoseconds, which applied to the discharge gap. For creating the pre-ionization in the discharge gap, we used the auxiliary spark gaps on both sides of the discharge gap. In this slide there are typical oscillograms of voltage, this, and discharge current in a mixture of air with CO2 addition. This field corresponds to breakdown of auxiliary spark discharges for pre-ionization. This laser generates a short laser pulse with half width of 50 nanoseconds. In this slide, the dependence of laser energy on concentration of CO2 in air is shown. We can see that the optimal concentration of CO2 is approximately 30%. We carried out a modeling of the situation of the operation of CO2 laser without helium, and in model we use the balance equation for the plasma, for main plasma components. The characteristic feature of this mixture is the absence of helium. The role helium in mixture of CO2 laser is to relaxate the level CO2 010, this level. The lower level of CO2 this relaxates according to this scheme. And we can see that constant of first and second reaction are large, the relaxation is fast, but third reaction is more slowly reaction, and this rates limits the relaxation of lower laser level. The constants with the participants of electrons we calculated using Monte Carlo simulation of electron motion in the electric field. The results of this simulation you can see in this slide and next slide. In this slide we see the constants of dissociative attachment for two mixtures. This mixture and the mixture with CO2 and air 50-50 and mixture with addition of CO2 of 10%. We can see that curves for 50-50 mixtures or mixtures of 10-90% are close. These facts explained, we can explain these facts in following way. The decrease of the addition of CO2 leads to increasing the molecular oxygen molecule, and this is and the addition of CO2, the attachment of CO2 molecules compensate the increasing of molecular oxygen, which is also attachment gas. In this slide, we saw the results of calculation of energy, of part of energy, which input in upper laser level for different mixture. This mixture is 50-50. I'm sorry. Так. This is part of energy will input in nitrogen, vibration excitation, and this curve input in upper laser level. It's for mixture 50-50. And this is curve for nitrogen vibration level, and this is a curve for upper laser level for mixture 10% to 90% CO2 air. It's the last slide. Using these constants, we have calculated the generation pulse for CO2 laser. We used mixture 50-50, exactly CO2 0.45, nitrogen also 45, and oxygen 0.1. For atmospheric pressure, specific energy 0.225 joule per cubic centimeter, and pulse front duration 50 nanoseconds. We use the approximation of ideal resonator, that is resonator without thresholds and without energy losses. And in real experiment with the real resonator, we will observe the delay between starting of pumping and starting of generation. And in real experiment, the tail of inertial pulse will also absent. And the conclusion of my report: the theoretical and experimental studies of operation of CO2 laser based on gas mixture with CO2 and air were carried out. It's shown that the change in the patch of CO2 in the mixture not lead to significant changing rate of dissociation attachment, and the optimal proportion of CO2 in mixture is approximately 30%. That's all.